So, first of all, there's quite a lot of stuff in here, but it's all just been published except for one little bit in this reference here. And so the acknowledgements for this talk are my co-authors, who you can read there, some of whom will be quite well known to this group. In many ways, we're not saying anything overly radical. Everybody in this group knows about the two-stage model, pre-eclampsia, both of which lead to oxidative stress in the current version of the Chris Redmond, Jim Roberts, Anatine staff view of the world. And a key point for us is that oxidative stress is a well-known cause of something called cellular senescence, which isn't just cells getting old as you might think it is, but it's actually a very systematic program, which we'll look at in a second. And again, here's another thing from Chris Anatine's and Jim's review in that reference cited, where oxidative stress is the key element of the development of preeclampsia and indeed manifestation. And as many of this audience will know, we think that one of the causes of oxidative stress is actually unseen infection coming from the father mainly, and that's all reviewed in great detail with a tremendous number of self-consistent references in those two reviews there. So cellular senescence is a deterministic thing, which is extremely widely studied actually, and obviously it leads to growth arrest of the cells and they stop proliferating, despite the fact that they would have perfectly normal growth and signaling conditions. An important aspect why a lot of people are very interested in it, independent of preeclampsia and pregnancy, is that autophagy, which is, we'll come into in a minute, but is getting rid of them, getting rid of senescent cells can increase the lifetime of an organism. So obviously people are very interested in that. But there is a lot of evidence that senescence is both a normal and an abnormal part of the development of in pregnancy and indeed in pre-eclampsia. And it has a variety of hallmarks whereby we say that this cell is senescent, has telomere shortening, persistent DNA damage, which is actually probably one of the most important things, a response to DNA damage, which is listed in the third bullet, and I won't go through in detail. And importantly, the secretion of a whole series of particular proteins that are pro-inflammatory, referred to as the senescence-associated secretory phenotype, or SASP, and one in particular is a beta-galactosidase that originates in the lysosome, SA-beta-gal. All of these have been observed in preeclampsia, and there's some nice reviews about that. Another aspect of senescence is morphological changes in addition to the SASP thing, and these are ways of determining whether a cell is senescent or not. Even if you're not going to get molecular markers, you can look at the size, the morphology, the nature of the nucleus, and cytoplasmic granularity. Again, all covered in this review. As I say, it's a very well-established thing. I'm not going off on a limb at all here. Now, autophagy is what is going to get rid of senescent cells, and how it works is by delivering what it says, protein aggregates and damaged bits to the lysosomes for munching and getting rid of the cells in question. And if you don't do autophagy as you normally might hope to do, you accumulate senescent cells, which is not a good thing. The basic idea is that if you've got a senescent cell, you don't want it anymore, and autophagy should help get rid of it, leaving the healthy ones behind. Now, there are two classes of drug molecule that help in this, referred to as senotherapeutics, and they're senolytics and senomorphs. They're two different classes of drug, both of which in affect or mediate autophagy. Senolytics actually induce apoptosis, which is a perfectly well understood thing, and I don't need to say anything about that anymore. More interesting for us is senomorphics, which stop senescence by suppressing the expression of the inflammatory SASP that we've seen, and we think the senomorphics are going to be important. Now, mechanistically, there's a transcription factor called NRF2, with that long name in the title. It's, in a sense, a standard transcription factor. It modifies the turning on of genes, and it works to counteract oxidative stress because it's going to turn on so-called antioxidant response elements. And one means of inhibiting autophagy and activating NRF2 is P62, and as we'll see in a minute, two small molecules that we're particularly interested in, spermidine and ergothioneine, also serve to activate NRF2. So activating NRF2 as a counteraction to oxidative stress is obviously going to be a good idea in stopping the development of preeclampsia. So NRF2 normally lives in the cytoplasm, where it is bound to something called KEAP1, which, as you see, has a cysteine on it. And in the presence of oxidative stress, the KEAP1 is removed and NRF2 heads off to the nucleus to turn on the antioxidant response elements called ARE in the cartoon at the bottom. And here's another version highlighting the fact that it's redox sensitive. So it's a redox sensitive transcription factor, as indeed is NF-kappa B, but we're not going to talk about that today, which when it feels oxidative stress, goes to the nucleus and turns on these antioxidative response element genes, of which there are a great many. Most importantly, lots of papers show that activating NRF2 can help to prevent preeclampsia. And a molecule that we're particularly interested in, shown there, is ergothioneine. That is one well-known activator of NRF2, and ergothioneine is widely available, in particular in culinary mushrooms, or indeed any other kind, but culinary ones for our purpose, and there's a review of its biology at the bottom there. Ergothioneine is heavily associated with improved response to cardiovascular disease. This is a study from Sweden in Lund, where they looked at the distribution of various metabolites in fact, 3,000 Swedish people, and asked the question, which of these metabolites are most associated with not having a heart attack or other cardiovascular issues in the next 3 years. And as you can see, ergothioneine won by a mile, and the next one along was proline betaine, which is quite similar, also known as stachyderine, which is actually a component of citrus juices. Now, this group will well know about the SCOPE trial, which goes back a long time, and Louise was a leader of that. And we were interested in the question of measuring in the SCOPE samples the amount of ergothioneine which we had hypothesized would be associated with, if a high level, not having pre-eclampsia. And that study was published a couple of years ago now. And here's the distribution in the overall population, which was slightly over 400 people, 97 of whom did get pre-eclampsia and the rest didn't. And the way that was distributed was that there were 74 term pre-eclampsia, 23 preterm, and 335 didn't. But interestingly, the means and the medians of the ergothioneine levels in these populations were essentially identical. So although it might have been thought to be a good biomarker, it isn't a good biomarker because the means and the medians are the same in the three classes. But when we look at the distribution between the three classes, we see that although the means and the medians, which are over around here, where all the clustering of the molecules is, are identical, if you take the 90th percentile, which is a standard thing one does, which was 462 nanograms per mil of ergothioneine, only one person got preeclampsia at all out of the 97, and of course, there were lots of controls as well who were above that level. And this is quite a huge difference between those two when you look at that odds ratio. It's a massive, massive odds ratio. And if I'd rather cheekily set it at 500, I'd have had no preeclampsia individuals at all. So if you look at those 97 now lumped together to make the numbers a little bit better, the distribution of ergothioneine concentrations in those, so that's a so-called cumulative distribution function, you can see there's really only a couple that are having an ergothioneine level over 400 nanograms per mil at all. So the question is, if you wanted to try and prevent preeclampsia by raising the ergothioneine levels, to what level should you seek to raise it in order to get a certain lowering of the risk of getting preeclampsia based on the starting at the 90th percentile, which is about 380, based on the extrapolation of the levels of ergothioneine in the individuals who got preeclampsia. And the way you do this is a slightly recondite statistical thing called extreme value theory, which this audience won't be overly interested in, but it's a principled method of doing what I want to do. And as you can see, if you get to 650 nanograms per mil, there's a much lower likelihood of getting preeclampsia, and that would be our target dose when you're seeking to do, as we hope to get funded for, an intervention trial. So overall, the story is, on the left-hand side, all of these things, as we know, leads to oxidative stress. And on the right-hand side, we're hoping that by inducing nerve activation by molecules such as ergothioneine, we can cause autophagy of the nasty senescent cells and thereby prevent the oxidative stress having bad effects in the senescent cells, having bad effects in the development of preeclampsia. So, in conclusion, we know that oxidative stress is a hallmark of preeclampsia, and we know that oxidative stress can induce cellular senescence. That's not news. What's important is that cellular senescence is actually important in the development of preeclampsia, and that one way to stop all of this happening is using nerve activators such as spermidine and ergothioneine. We've happened to have a focus on ergothioneine, but I wouldn't say that spermidine would be a bad choice either. And there's an absolutely clear correlation between not getting preeclampsia and having a high level of ergothioneine in your plasma. I might say that ergothioneine has its own transporter. Evolution has selected for it. It's also accumulated in erythrocytes. So if you start managing to build it up and you miss a few days, it doesn't matter, because there's a good buffer of about 10 times higher concentration inside erythrocytes. So what we need to do now, and wish to do, and are trying to get funding for, is to actually test ergothioneine as an independent variable where you give it to people and see whether it's protective or not. And as I say, that's the paper where you can find everything except the extreme value theory, which is a more recent thing. And with that, I thank you for your very kind attention.
Doug, thank you very much. That was fascinating. Did you talk about it? Maybe I missed it, but I didn't think I had. Whether or not whether your level of ergothioneine is gestation specific, and at what gestation you would consider loading people with ergothioneine to reduce their risk of preeclampsia?
So those numbers were obtained at week 15 when that was looked at there, and we're thinking of starting around week 12 to 15 would be the time to start an intervention, partly because some of the developmental things have happened earlier that people might be worried about.
And then that would be giving ergothioneine throughout pregnancy from week 15 to delivery.
Yeah, I mean, the usual doses that people have done, the pharmacokinetics have been done by a group in Singapore led by Barry Halliwell, not on pregnant women yet, so we're in the throes of trying to get that done. But as I say, there's a good buffering inside erythrocytes, and the sort of doses you give people in these kinds of studies are 5 to 25 mg a day, and we'd actually aiming to do an adaptive trial where we now look to get up to our target level and then seek to maintain and not go above that. And we will do the measurements of the plasma levels, of course, at the same time.
Thank you. So I suppose my other question is, what are the potential side effects of ergothioneine?
As far as we know, none. And people have been, it's been through the European EFSA, European Food Standards Agency, and the US equivalent, using absolutely industrial quantities of the stuff. And of course, it is prevalent in mushrooms, which people eat all the time, whether they're pregnant or not. So we genuinely cannot see any reason why you should expect to be side effects of ergothioneine.
Thank you very much indeed. This is obviously an area that we're all going to have to keep an eye on over the next, I don't know how many years, to see where that's going. Absolutely fascinating. Thank you very much indeed.